first MIMC problem explaining section. So we have the tiebreaker, which is let f of x be a function such that f of x follows these rules. In the domain of f of x are all non-negative integers. And we have f of 0 is equal to 1 and f of 1 is equal to 1. Then we want to find the range of the function. So this is from the tiebreaker of Algebra and MIMC series conducted in September back in 2021. So we have f of 0 is equal to 1 and f of 1 is equal to 1. So claim is that the range only contains 1 for all non-negative, no, for all natural numbers. Okay, so this is the claim. So how do we prove this? Let me just make this smaller. So first we have to find some basic cases. So f of 0 is equal to 1, f of 1 to 1. What about f of 2? F of 2 is equal to f of 1 plus 1, which is equal to f of 1 squared plus 1 squared minus 2 times 1 times 1 equal to f of 0, giving us f of 1. Or you can also do it as f of 2 times 1, which is f of 2 times f of 1. So f of 2 gives us 1, so it's kind of the same. So what about f of 3? So f of 3, write as f of 1 plus 2 equal to f of 1, because 2 squared plus 1 squared minus 2 times 2 times 1 is equal to 1. So we can actually rewrite this as f of a plus b equal to f of a minus b squared. So now the explanation, the proof comes from the following. So notice that f of 2 is equal to 1, and f of 1 is equal to 1, and f of 0 is equal to 1. They're actually really, really important. So we also know that f of a plus b equal to f of a minus b squared. So how is that going to help us? So for all odd numbers, that's called O, as can be written as 2n plus 1, and it's less than O, which can be written as n plus 1, because we split n as n and n plus 1. 2n plus 1 can be split into n and n plus 1. Then we can see that if we plug it into here, then we're going to have f of 1 squared, which is equal to f of 1, which is clearly equal to f of 1. So we're done for the proof for all odd natural numbers. How about even numbers? Well, even natural numbers is also straightforward. So we can say f of 2 times O, 201, which O1 is an odd. Then we can write it as f of 2 times f of O, which we know that f of an odd number is always going to be equal to 1, which is equal to 1 times 1, which is equal to 1. So we're done with the proof.